Trig with me, Mr. Hamilton and Mr. Parker's class, talking about matrices, talking about multiplying matrices. It can kind of be tricky. So, want to ease your pain today. Want to take one more day with multiplying matrices and, a little more practice. So, first, I want to talk about the commutative property. So, in multiplication, we have something called the commutative property. So 4 times 5, we all know that that is 20. The commutative property allows us to switch the order. And if the order is 5 times 4, since that is the same product, we say that multiplication is commutative. It doesn't matter what order we multiply things in. And that's for any real number. And that's an important property for us when we're solving equations. We're now going to use matrices to solve some things in a moment. I shouldn't say now, but in a few days. So we want to look at, are matrices commutative? That's our essential question. Are matrices commutative? Can we switch the order? Well, let's take a peek. So what we're going to do here is I'm going to take a look. Does the order matter here? So we have two matrices. We talked about steps for this. Select the order of the product. If I'm going to multiply these, this is matrix. We'll call this matrix 1, this matrix 2. I find the order of these. These are a 2 by 2. This is a 2 by 2. Since these match, it is defined. This is the order of our answer. 2 rows, 2 columns. So that's what I'm going to do first. I'm going to set that order. I just know I need to have 4 elements in this. 2 rows, 2 columns. First element is going to be made up of the first row of the first matrix times the first column of the second matrix. So sometimes what I use, here's an alternative method. I use my fingers here. So I'll place my left hand, because I'm a righty. I'll write with my right hand. But my left hand, I'll place my left finger on the first element in the first column, and my right hand on the first element in the first column. And I'll multiply those, and I'll say that out loud. 2. And then I'll move my left hand to the right across the row, and my right hand moves down. 0. So I'm always saying the product of these. Instead of writing them out like I did yesterday, I just say the product. I'll do it again. 2, 0, and then I add those in my head. I write that number there. And then I just repeat. So this spot right here, I'll put a box around it. If I'm going to find this, the address to this is first row, second column. So left hand deals with rows. Right hand deals with columns. I'm now going to use this column. So first row with my left hand, second column with my right hand. 8, 0. And then I add those up. And then I repeat. So now as I move down here, this one right here, this is second row, first column of the product matrix. So my left hand goes on the second row. My right hand goes on the first column. So 3, 2, say the product out loud, 3 and 2. And then I can add those using mental math and just repeat. 12, 3. So 12 and 3, 15. Done. Okay? Now, let's just take a look. Let's switch the order of these. So we'll use, I'm going to use another board here. I'm going to switch the order. So now we're going to go 1, 4, 2, and 3. Switch the order of the matrices here. 2, 0, 3, and 1. We're going to see if it is commutative here. Well, we already know the answer in this direction is 2, 8, 5, and 15. Let's switch the order. It's a 2 by 2, so I'll use my hand trick here again. 2 and 12. 2 plus 12 is 14. Now, right out of the gates, look at, I got an issue. That address is not the same. In this order, the address or the element was 2. In this order, it's 14. So it's not going to be commutative. Check it out. 0, 4. Move down to here. Second row, first column. 4, 9. That's 11, 9 and 4 is 13. 0, 3. There you go. You can see that is not equal to this one. 2, 8, 5, and 15. They are different. So our essential question is matrix multiplication is not commutative. The order matters. It may be, there are certain ones that are, but in all general terms, order does matter and it's not commutative. So the last thing I'm going to do is I'm just going to show you using the hand trick here with a large 3 by 3 on how I might go about this. Let's move this up a little bit here. And this is it, just more practice today. So if I'm going to do a 3x3, first of all, I set the order of the product matrix, make sure these are defined. If they are, then there's going to be 3 rows, 3 columns. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. Kind of ran out of room there. Okay, so this can be intimidating. This is where my hand trick comes in. 0, 0, positive 2. If you got a lot of zeros, you can add those numbers quick in your head. Now keep your left hand on this first row. Just take your right hand, slide it over to the next column. 0, 0, 0. Move it to the last column. 0, 0, 0. Remember what I'm doing here is I'm saying the product. So my fingers are pointing here. I'm saying the product of 0 and negative 1, which is 0. And then I'm saying the product 0, 0. Each time my fingers move, my left hand's moving to the right, my right hand is moving down. Now I just repeat. Take my left hand, move it to the second row. Take my right hand, move it back to the first column. 0, negative 1, negative 3. Negative 1, negative 3, that's negative 4. Repeat. Move this one over to the right one. Negative 3, positive 2, and 0. Negative 3, positive 2. Sometimes you might want to write them down. Positive 3, negative 1, and 0. Positive 3. Whoa, that's not negative 1. That's negative 2. So positive 3, negative 2. That's positive 1. And then let's go to the last one. 0, 3, 0. 0, 3, 0. Go to this one. 0, negative 6, 0. And then the last one. 0, 6, 0. Voila. Check your work. Slow it down. All good to go. Hopefully you guys are in a good spot. Be good, my friends. Until next time, stay clean, wash your hands, disinfect your phones, and most importantly, be kind.